Hope you guys had a good weekend. Had a great weekend, especially football-wise. Tremendous great time. Let's see. Oh, I'm going to put this up on here. Screen. Start off. We got some good stuff to study today in Algebra 3, but we're going to get to the important stuff first before we get to the algebra. It's a Fat Bear Week, so I typed that in the search. Fat Bear Week. We're down to the finals. Today and tomorrow is the last days of Fat Bear Week. We've had the earlier brackets, but today's vote, which doesn't start till 11 because they're on Alaska time. If these bears are in Alaska. Let's see. Today, Chunk versus 901. Chunk here on the left. He's a big boy this year. I think he's got a chance to finally win. He's never won. I think he's got a chance to win. The other vote today is down here. Grazier versus Holly. Both of these are lady bears. Grazier's pretty big. I think Grazier's going to beat Holly today. We'll see. But those two. And then Chunk versus 901 up here. And the winner of these will face off tomorrow to be this year's Fat Bear champion. Fat Bear champion. So just go search Fat Bear Week and you'll see the voting link and you can vote on the Fat Bear. But it doesn't start till 9 a.m. Pacific, which is 11 o'clock our time. That's when they'll open it up there in Alaska and get your Fat Bear. So see if I can get Chunk a victory this year. Chunk needs to win one of these years. He's tried so hard. He's been eating all he can to try to be the fattest bear out there. Okay. Oh, before I get into the lesson, let's talk about this real quick. Next week, we don't have school on this Friday because it's fall break, and we don't have school next Monday. It's fall break. So you won't have an assignment until Tuesday morning. But next week's kind of weird. Notice I don't have anything up here on this Friday because there's no school Friday. Next week, our A days are Wednesday and Friday, right? So next Friday will be an A day. But Wednesday is the PSAT and the work keys and the community service for freshmen. Everybody's got something going on Wednesday. We don't have class Wednesday next week because of the PSAT day and that kind of stuff. So seniors will be up here at the work keys. Juniors and sophomores will be doing PSAT, freshmen. So we don't have any class next week except for Friday. Now, I don't want to wait till Friday to give you guys the lesson. So I'm going to make a recording, and I'm not going to assign as much next week. I'm going to cut that down. We'll look at that. But I will make a recording of the lesson, and I'll post it Tuesday so you can go ahead and do the assignment whenever. I don't want you to wait till Friday for an assignment due Sunday. So I'll assign things Tuesday morning. I'll post a video of the lesson, and we will not meet on Friday unless your grade's below 70%. So you still have to be here Friday next week if your grade's below 70%, but get your grade over 70% next week and don't worry about that. But that's the only class period we have next week. So I will officially not hold class as a group next week just because of that. And I'll cut down how much I assign next week. But I will have a video lesson for you to watch so you can do that. So, all right. Now we got that out of the way. But I will be here Friday next week for anyone that needs help and for anyone that has to be here. But this week, no Friday at all. So, okay, let's get down here to first hour Algebra 3. Let's go to our grade screen. So you should have finished up the Module 2 test. That's what was due yesterday. Module 2 practice test and the Module 2 test should be done. Hopefully you're ready to rock and roll. So look, this week we've got 3.01, 3.02. Next week you just have one thing, theorems of algebra. And I will make a video over that. Then the next week we'll get to the rational root system theorem and Descartes' rule of signs. I'll put that with the next week. So we have 2 lessons the week after that with a quiz. And then, so we'll be finishing up before Thanksgiving with this unit. But this week we have 2 things. Polynomial long division. Boy, that just sounds scary. Nah, long division. You did that in elementary school. You didn't do it with polynomials. I guarantee you that. But we will today. And synthetic division. These kind of go together. So that's why we have both of these lessons. They very much go together. So let's look at 3.1. 3.01 right here. All right, I'm going to close module 2. We tested. We're done with that. We are ready for module 3 here. Long division. Well, I better get my camera launched up here too. We're going to have to do some. We're going to have to do some math today. I'll get that ready to roll. Get that ready to roll right there. Okay. We'll get back to that. Polynomials in the real world. So a cantilever, here's a cantilever, is a beam that's anchored only on one end, but can still bear the weight of some force. These beams are used in a variety of applications, from bridges to airplanes to micro-electromechanical systems. Well, that's a word for you, right? Use that one in Scrabble. Micro-electromechanical. The amount of bending a cantilever undergoes is a third-degree polynomial function of the cantilever's length. So many real-world situations can be modeled using polynomial functions. That's why it's important to know how to use them. So one key feature is when these polynomial functions equal 0. That always tells us a lot about a function. So it makes it easy to construct a rough graph and know how a function will behave by figuring out what's it look like when it's equal to 0. So we're going to learn how long division can be used to find the factors of polynomial functions. So division of a polynomial by a monomial. When you first learn long division, way back in elementary school, you probably didn't understand its purpose. But now that you're older and wiser, you can see many uses for knowing how to divide. Let's say you accept a part-time job at a bakery. The baker sells a bag of rolls containing 13 rolls, which is a baker's dozen. Used to be a baker's dozen. You order a dozen, the baker would give you an extra one, 13. There's known as a baker's dozen. So the baker made 158 rolls before he left for the evening. And he says he wants you to make sure that each roll is packaged before going home. So what's the greatest number of bags you'll need? And should you try to sell any extra rolls so you won't have any leftovers? So you take the 158 and you divide it by 13, right? So you put 158 rolls in the groups of 13 in order to find out how many bags to create. You got to divide that. Here's a review on long division. Just a quick review because we'll be doing this with polynomials. So you have a divisor, a dividend, and a quotient. The dividend is the number you're dividing into. The divisor is the number you're dividing by. So in this case, 158 is our total that we're dividing into. We're dividing it by 13, and the quotient is going to be the result. So you take the 13, it won't go into 1. So you look at the first 2 digits. How many times will 13 go into 15? It'll go into it 1 time. So you take 1 times 13 and put it underneath there. Has a remainder of 2. You bring the 8 down. So now you have 13 divided into 28. How many times will that go in? It'll go in 2 times. So you put it next to, and when you multiply that back, you have a remainder of 2. So 158 divided by 13 is 12. They'll go in there 12 times with a remainder of 2 13ths. 2 out of 13. There's checking your work. You go back and you multiply it back. 12 and 2 13ths. You make this an improper fraction. 158 over 13. 13s cancel out and it comes back to 158. So, all right. Just a review on long division. The steps used to divide polynomials is exactly the same as used when dividing integers. So try the following phrase to help you remember the steps. Discovering math solutions bring rewards. Means divide, multiply, subtract, bring down the next number, and repeat. So here's a video on how to divide. And we're gonna do this on paper, but if you want to watch the video, it's about 4 minutes and 42 seconds. But I'm not going to play the video. I'm going to actually do this on paper. So I'm going to write down the 2x to the third minus 10x squared plus 18x. And we're going to divide that all by 2x. All right. So let me put it up on the screen here. There we go. So long division. So the first thing we look is the first term. Can we divide 2x into 2x to the third? We can, right? It'll go in there x squared times. Because when we multiply this back, 1x squared, really, 1 x squared. It'll go in there one time of x squared. Wait a minute. All right. I don't want to do this differently than they're doing it on here. So they're going to put the same thing. Divide by 2x. So it goes in there 1x squared times. Okay, they're doing it the same way. They're doing it the same way. I just don't want to confuse you by doing something different. It goes in there 1x squared times. So when we multiply that back, 1x squared times 2x, you get 2x to the third. When you subtract that, you get 0. So you bring down the next term, negative 10x squared. So how many times will 2x go into negative 10x squared? It'll go in there negative 5x times. Because when you divide negative 10x squared by 2x, right, when you cancel out, because this is x times x squared and x just leaves an x. Negative 10 divided by 2 is negative 5. Negative 5x. So you're just dividing in there. When we did this, we had 2x to the third, which I'll write like this. 2x to the third divided by 2x. 2 cancels out and x cancels. It just leaves x squared. That's how we got the 1x squared. Negative 5x. So negative 5x times 2x is negative 10x squared. That leaves a 0. So we bring the next term down. It gives us positive 18x. How many times will 2x go into 18x? 9 times. 9 times 2x is 18x. Remainder of 0. So if we divide this by this, the answer is x squared minus 5x plus 9. Just using long division. Just like when we were dividing 5 into 23 years ago in elementary school. How many times 5 go into 2? Won't do that. 5 into 23 goes 4 times, which is 4 times 5 is 20. Remainder of 3. So remainder of 3, or you would say 4 3/5. But we did the same thing using polynomials. And you're like, oh my goodness, why in the world would we do that? Well, because now this gets to something we can factor. We know 2x is one of the factors of this. 2x is one of the factors. Then we can find the factors of that. It's hard to find factors of a cubed. We know how to find factors of a quadratic, but finding factors of a cube can be harder. So we can use long division to do that. Okay, all right. So they'll get down to the end of it and they'll come up with the same solution we did. Yeah, 2x to the third. Oh, that's checking it. There's checking it. X squared minus 5x plus 9. That's what we got. And then they're checking it by multiplying it back together and seeing that you get the correct answer when you multiply them back together. Learn more. There's lots of extras in here. Polynomials divided by a monomial. Because a monomial means one term. Negative 3x is a monomial. Mono means one term. Polynomial means many terms. So this is 2 terms divided by 1 term. So it goes through each step of this. So if you need another example of that, so here's negative 3x divided into 12x squared minus 27x. So it will walk you through. So I'll leave that for you to go through if you want another example. But let's get into the lesson because we'll be doing more examples on these following pages. Okay, polynomial division of a polynomial by a polynomial. Ooh, all right, let me write this one down. X squared minus 2x plus 4 divided by x minus 6. So you'll see when they start this one, again, I'm going to turn the sound off. They'll take and they'll put what they're dividing into goes underneath the division symbol. And what you're dividing by will go outside the x minus 6. So then they have to look and say, okay, this is two terms. So we look at the first two terms. And how many times does the first term, we just look at the first term, how many times will x go into x squared? But if we divide x squared by x, it equals x. It goes in there x number of times because x times x is x squared. So now you have to multiply that number by the bottom there. Here, I'll work this on paper here. So we have two terms that we're dividing by. So we look at the first two terms of what we're dividing into. So x goes into x squared. X squared is x times x. And if we divide it by x, it goes in there x number of times. I'm going to put it, I'm going to have to put it over here. So x times x is x squared. X times negative 6 is negative 6x. So we subtract these. Subtract x squared minus x squared is 0. Negative 2 minus negative 6x. Subtracting a negative, which means we really just add that. Because you subtract the negative, it's adding. So negative 2x minus a negative 6x is just adding. And window was 4x. Now we need to bring down the next term. How many times does x go into 4x? Goes in there 4 times. So 4 times x is 4x. 4 times negative 6 is negative 24. Oh, wait. We're subtracting that again, which means it's a plus. So this is a 28. And it's a plus. So the remainder is 28. Or so we would say the answer is x plus 4 plus 28, x minus 6s. Here the answer was 3/5 because we were divided by 5 and have a remainder of 3. So 3/5 is our leftover. Here we're divided by x minus 6. We had a remainder of 28. So it's 28 x minus 6s. But you got to remember when you're subtracting, this minus becomes a positive because these were minuses. But subtracting a negative means you add. So let's see if they got the same thing or did I make a mistake here? Let's see. Get down here. I'm just fast forwarding in their video. It's about a 4-minute video. Come on, video. Loading very slowly today. Okay, so they got the x plus 4. Subtracted, remainder 28. There it is. X plus 4 plus 28, x minus 6. That's just exactly what we came up with on paper. And then when you're subtracting, you got to end up adding. Example 2. All right, they're phrasing it a little differently, but it works the same way. So let me write it down the way that they're doing it so we can talk about how to set that up properly. See if x equals 3x minus 1. And it wants f of x divided by g of x. Okay, so here's what they're doing. Said f of x is equal 9x squared plus 6. G of x is 3x minus 1. And they want f of x divided by g of x. Okay, well, f of x is going to be underneath the division because that's what we're dividing into, and we're dividing it by what's here. So the 3x minus 1 is going to go out here. Now, here's the important part of this. If we're going to divide that into another polynomial, we have a missing term here. We have 9x squared and then just a number. Well, what happened to the x term? Well, there's no x term in here. When we write this in a division problem, we have to include that x term. There's 0 of them. But in order to properly divide two polynomials, you have to remember that that actually is there, but it has a coefficient of 0. But if you don't include that, you're going to have a problem when you check your work. All right, so 3x minus 1 would go into 9x plus 0x. How many times does 3x go into 9x squared? 9x squared, 3x. And notice I write x squared this way because it makes it easier to divide. X times x is x squared. Well, x goes into x one time. This simplifies to a 3 on top. So that's 3x, right? So 3x is how many times that 3x goes into 9x squared. Because 3x times 3x is 9x squared. So let's multiply that, 9x squared. Negative 1 times 3x is minus 3x. Okay, let's subtract that. 9x squared minus 9x squared is 0. What's 0 minus negative 3x? It's a positive 3x. And let me just say, when I'm looking at student work, when I'm grading this, the problem I see most often is this right here. When I see an error in your work, most of the time, it's going to be you forgot you were subtracting a negative and you made this negative 3x. If you have 0 minus negative 3, that means you add it to make a positive 3x. We subtract a negative. Oh.
What keys? One seems asking if there is BWHS coming here too?
Yes, they all come here.
Okay.
All right. As Mrs. X had a question there for work keys next week. All right. So this is the mistake I will see most often. So double check yourself. If you need to put it in parentheses to remind yourself, I'm subtracting both terms, if that helps. All right, let's bring the next term down. Plus 6. So how many times does 3x go into 3x? 1. So 1 times 3x minus 1 is 3x minus 1. And we're subtracting that. This is 0. 6 minus negative 1. 7. So our final answer is 3x plus 1 plus 7 3x minus 1s. Because we had that remainder of 7, and since that's our divisor, it's 7 3x minus 1s. You're like, whoa, that's how it would work. If this was just a number, if this was ninths, it'd be 7 ninths. It just happens to be that we're using a polynomial, 3x minus 1. All right, so they'll go all the way through all of that and end up with the same thing. 3x plus 1 plus 7 3x minus 1s. All right, important note. Take a look at the quotients, which is the answer. In example 1, example 2, the division resulted in a remainder. Okay, so what that indicates is that the divisor was not a factor. So that's a very good point. It's not a factor. So if we're trying to factor this 9x squared plus 6, we're trying to factor that. We're saying, okay, what are the factors that would multiply together to be 9x squared plus 6? 3x minus 1 is not one of the factors. How do we know that? when we divide it into there, we don't end up with a remainder of 0. If it's a remainder of 0, it would perfectly divide into there, and there wouldn't be any left over. Wouldn't be any left over at all. If we were factoring it, that would be one of the factors. But since there is a remainder, this is not a factor. Same on this one. This had a remainder. It's not a factor. This one had a remainder of 0. So if we were breaking this out, we know that 2x is a factor, and then there's still an x squared. So there's still 2 more factors. But we know 2x is one of the factors of this original equation. Then we would factor that out, which we could use the quadratic formula or whatever we need to do that, because we're not going to get negative 5x plus 9 by just doing 2 nice factors. It'll be more complicated factors. But we know 2x is one of the factors. It would divide out of there and leave perfectly. So that's what doing this division to help you do, is find the factors of a higher level polynomial. All right, let's look at page 3. Applications. So if we have this box and we know the volume is x to the third plus 4x squared minus 31x minus 70, and we know the length and we know the width, we can find the height by doing some polynomial division. So we know the volume is the length times the width times the height, and we know the length and the width. So if we divide those into the volume, that'll tell us what the height is. So since the volume is this, the length is this, and the width is this, divide those into that, which we can multiply together at the bottom. If we multiply those together, that gives us x squared plus 2x minus 35. So we just divide the volume by the length times width multiplied together. And that'll give us the height. So divide the numerator by the denominator following the steps of polynomial division. So how many times does x to the third go into x squared? Are they wanting us to get the final answer here? I think they're just want to just do one step at a time. So it would go in there x number of times. Let's see what they're doing. Oh, this is a long one. Okay, they want us to put the final answer in there. So let's try to see if we can't work this final answer. Let me write this one down. X to the third plus 4x squared minus 31x minus 70 divided by x squared plus 2x plus, minus, not a plus, minus 35. All right. Woo. Getting some real polynomial division here. The only way you're going to get good at this is by practicing. You can watch me do it all day and you'll still struggle. So we're going to take the first 3 terms and divide it into the first 3 terms here. But we just start with the first term. How many times does x to the third go into x squared? I mean, if we divide x to the third by x squared, that's what I mean. Take x third divided by x squared. These cancel out. This it just equals x. It goes in there x number of times. So x. So x times x squared is x to the third. X times 2x is 2x squared. And x times negative 35, negative 35x. Subtract all of that. Subtracting. 0. 4x squared minus 2x squared. 2x squared. 31x minus negative 35x. So we got 2x squared plus 4x. Bring the next term down. Minus 70. So how many times does x squared go into 2x squared? 2x squared divided by x squared. Well, these cancel each other out. It just goes in there 2 times. So plus 2. 2 times x is 2x squared. 2 times x squared. 2 times 2x is a 4x. And 2 times negative 35 is negative 70. When we subtract that, they're all the same. Remainder of 0. So x plus 2 goes into that perfectly. The height is x plus 2. That is the height of the box. So it's x plus 2. Let's see if that is correct. That's the height of the box using polynomial division. Then you can look at the way they solved it. They did the same thing. They divided all the way through it to get to the x plus 2 with the remainder of 0. So x plus 2 is one of the factors. The way you can get that, if you multiply x plus 7 times x minus 5 times x plus 2, that will give you the x to the third plus 4x squared minus 3, because those are all factors. That's the 3 factors of that x to the third equation right there. 3 factors of that. Because we had a remainder of 0, so we know it's a perfect factor. All right, there's our lesson summary. You just have to practice it. And remember that if we have x to the fourth minus 1, when you're dividing, you need to put the x to the third, the x squared, and the x terms in there, the coefficient of 0, or else you're going to get wrong answers. Okay, let's look at that. There's lots of practice problems here for you. Try these. Submit to see if you're correct. And I strongly recommend on this polynomial division that you do these practice problems, because you're not going to get this until you try it and practice it. So divide this by 5. They start out easy, just giving you one, dividing it by 5. What does it end up with? Choose your answer, submit. Go to the next one. Okay. We've got 3 problems right here. Divided by 7x. They get a little more complicated. All right. So after you get through with those, there's some more right here. You try 2. Now it's dividing by x plus 7. After you get your answer, check your work. See if you get the same thing they did. Same remainder and all of that. And there's multiple problems there. Oh, it's moved off where I can't see it. How many problems are there? I'm not sure. Looks like there's maybe 5, 10. Okay, the next page. Got some more practice problems. Practice. Match each division problem below to its correct quotient. Okay, if you divide this by 4, which one of those answers do you get? So there's going to be 6 problems here. So you have to write this down on paper, 40x squared plus 8x plus 20, and divide it by 4, and see which one of those answers you need to drag that to, right? If you drag it to the right one, it should disappear, right? It's obviously not that one. It's not disappearing. Maybe it's that one. Oh, there. I'll put it right there. There. What's underneath it? So, great practice there. And after you do this one, there's 2 more pages. All right, let's look at the assignment that goes with this. There you go. Divide this by this. Which one of these is it going to be? If f of x is this and g of x is this, what is it when you divide f by g? So you have 5 problems. Now let me show you synthetic division. Polynomial synthetic division. You want to pay attention here. You're going to love this after you do the polynomial division. This is so cool. This is a shortcut. I know how you love shortcuts. All right. Add these numbers, 3, 3, 3, 3, 3, 3, 3, 3, and 3. What'd you get? 27? Let's see. Chances are good you multiplied 9 times 3 and got 27, because there's 9 3s there. Okay, I took a shortcut. 9 times 3, 27. There's 27. Is this number divisible by 3? 45,789,102. Is that divisible by 3? Yes. Hopefully you didn't actually divide that by 3 to find an answer. You just go find the sum of the digits. If you add all those numbers together, 4 plus 5 plus 7 plus 8 plus 9 plus 1 plus 2, that equals 36. And since 36 is divisible by 3, that means this number is also divisible by 3. Ah, cool shortcuts. Don't you love shortcuts? Multiply 34 times 11. Did you get 374? So the quick way to do that, if 11 is being multiplied by a 2-digit number, sum the digits and put that in the middle of those digits, like 34. Add those together, which is a 7, and then put the 7 right in the middle of the 3 and the 4, and you get 374. It's a shortcut when you multiply by 11 and a 2-digit number. So you add those together. 3 plus 4 is 7, so it goes in the middle of the 3 and the 4. Note, if the sum of the digits is a 2-digit number, you got to carry any ones to the first digit. Like 97 would add together to be 16. So you wouldn't put 16 between the 9 and the 7. You'd put the 6 between there and add that 1 to the 9. So 1067. But this is using a shortcut, right? Well, there's a shortcut to polynomial long division, and it's called synthetic division. So here it says another review on long division. If you want to look at another practice problem on how we divide 2x to the third minus 3x squared minus 12x minus 16 divided by x minus 4. There's all the steps again till you get way down here and finally get this answer. A lot of steps, 13 steps. But let's compare synthetic division. All right, I'm gonna write this problem down. So we've got x minus 4 divided into 2x to the third minus 3x squared minus 12x minus 16. All right. We've seen how to do this with long division. But there is a shortcut called synthetic division. Oh, there's an N in there. S-Y-N-T-H. I see. Synthetic. Instead of doing all of this work with the polynomial long division, we can just bring down the coefficients. See the coefficients? 2, negative 3x squared, negative 12x minus 16. Just the coefficients. And I'm going to divide that by, instead of x minus 4, what would that be if for 0, x would equal 4. So if I divide it by 4. Okay, all right, Mr. Brock, what are you doing? Well, I got rid of all the x's. I'm just using the numbers. So this time I'm going to do this. I'm going to bring down the first number. 2. And I'm going to take the 4 times the 2, which is 8. Right? 4 times 2 is 8. I'm going to add these together. Negative 3 plus 8 is 5. And then I'm going to multiply these now. 4 times 5. 20. Negative 12 plus 20 is 8. Multiply those. 32. Add those together, I get 16. So I'm saying, using synthetic division, that if I divide this by this, my answer is 2x squared minus 5x plus 8 with a remainder of 16x minus 4s. What? You didn't do all the work. Well, I did. I used a shortcut called synthetic division. And so this is now the coefficient when you divide by an x into an x third, you know the largest term is going to be x squared. So all you do is you take whatever this term is and you subtract 1. So instead of x to the third, it's going to be x squared. And so these are the coefficients of the x squared, the x, the number, or the x to the 0 term, and then the remainder. You're like, you got to be kidding me. It's got to be harder than that. No, synthetic division is not. There's just some limitations. So here's the steps. That's the long division. That's the long division right there. Oh, it's plus 5. Yeah. That's the long division. Here's what synthetic division is. You just take the coefficients, the 2, the -3, the -12, and -16. Instead of x minus 4, you take what x would equal to be, make that 0. See, the 4 comes from there. It's the opposite of this. Since that's a -4, you take a +4. If this was x plus 4, we would take a -4. We take the opposite. And the numbers there are the coefficients there. And that's when we multiply. 4 times 2, add those together, 5. 4 times 5, that's 8. 4 times 8. And then those are the numbers that go back. So that's how long divisions, synthetic division are like. They use the same terms, but see, there's a lot more steps with the polynomial division. Then synthetic division just goes like that. Is that the same problem? Yeah, that's the same problem there. Okay, let's go to another example. All right, we're going to do another example here. We have x plus 7 being divided into x squared minus 2x minus 63. All right, so we're dividing this into that. Let's use synthetic division. X plus 7. That's plus 7. We use the opposite, -7. What's the coefficients? X squared is 1, x is -2, and -63. First number just comes down. So we have something to multiply by. -7 times 1 is -7. Add these together. -7 times -9 is a positive 63. So there's no remainder. So if we divide x plus 7 into this, we get 1x minus 9, and the remainder is 0. So that just told us that this factors into x plus 7 times x minus 9 because there is no remainder. So this is one of the factors of x squared minus 2x minus 63. If you factor that, you'll get these two factors, this one and this one, because there's 0 remainder. So we know this is one of the factors. And when you factor that out, there's the other factor. So we're able to factor that using synthetic division because the remainder was 0. Well, that's pretty cool. What else we got? This is a good one because we need an example like this. Okay, so f of x is x to the third plus 3x squared plus 25, and g of x is x plus 5. And we want to find, again, f of x divided by g of x. All right, let me move it up. So let's set up our synthetic division. X plus 5. That's plus 5. So I'm going to divide by -5, the opposite. And I've got to write down the coefficients of the terms. But this is where you have to be careful. I've got x squared and I've got just the number. What happened to the x? We have to include every term starting with the biggest one. The biggest one is an x to the third. So what's the coefficient of x to the third? It's 1. After x to the third, be x to the second. What's the coefficient of x to the second? Oh, it's positive 3. After x to the second, be x to the first. What's the coefficient of x to the first? I don't see one, so it must be 0. So after x to the first will be just the number 25. If we leave out the 0, we're going to get the wrong answer. When you're missing a term, you have to include that term, but realize that the coefficient's 0. Because that's the same thing. This is the exact same equation. That's the exact same equation. Exact same function. It's just when we have 0 as a coefficient, we leave it out. This is wasted energy for us to do this. That's why we only write it like this. But synthetic division or long division, either one, when we're dividing, we got to put that back in there. Okay, first term comes down. 1. -5 times 1 is -5. Add those together. Multiply this. +10. Negative times a negative. 0 plus 10. Multiply those. Negative. Oh, that's a negative, not a 25. I'll look at the number up there. -50. So -25 is our remainder. So when we divide f of x into g of x, we get, it started as an x to the third, so this must be x squared. There's the x term. So it gets an x term when you divide into it. Plus 10 minus 25. We divided by x plus 5. So there's our answer. When you divide f of x by g of x, you get x squared minus 2x plus 10 minus 25 x plus fifths. Let's see, what did they do? X squared minus 2x plus 10 squared plus, and then they got 25 as the remainder. So minus 25 x plus fifths. All right. Here's where you can set up your own, it says. Create your own 5th degree polynomial that has a remainder of 1. So I want you to just make those up. So it made up a x to the 5th plus 2x to the 4th minus 20x to the 3rd minus 25x squared minus 5x plus 180. Has the remainder of 1. So they figured out to make that 180 a 165 because when they did it all there. That's just playing around with it. There's the lesson summary on synthetic division. So synthetic division is a lot shorter than long division, but you got to make sure you do the steps correctly. Here's some practice problems for you to practice. Got 6 of them here. Love it. 6. Get pencil and paper out. Try this by synthetic division, and then check your work. Did you do it like that? See how few steps it takes? Long division takes a lot more steps, but you just have to make sure you're doing it correctly. Check my work. Check my work. So you get some of these now. It's got x to the 3rd plus 1. It left out the x squared and the x. You have to include those zeros when you're doing this synthetic division. All right, let's look at our assignment for this week. I'll go back and make sure you have multiple attempts at this. Divide this by this. Which one of these is it? Divide that by that. Which one of these is it? Which one of these is it? 5 problems. 5 synthetic division problems. Again, you have to practice to get good at this. If you just look at it and just try to do it, you're going to struggle if you don't practice them. And there's lots of practice problems in the lessons that let you do the work and then check your answer to see if you did it right and tell you how to do it if you miss something. It's just about not missing steps. And the biggest step you're going to miss is with long division, you're going to forget you're subtracting a negative, because I see that a lot. And with synthetic division, you're going to forget that there's no x term or no x squared term, and you're going to forget to put that 0 in there for the coefficient. That's the things to watch for. That's the mistakes I see most often when students practice this and try to do this. That's the steps they mess up. So pay attention to the details And you can do this. It's just you need to practice it. Need to practice it. But these kind of go together. Long division, synthetic division. Long division, shortcut. That's really what it is. All right. I won't keep any longer, guys. Hang around if you got questions. But I will let you go. Fat Bear voting is in an hour and 12 minutes. Chunk can do it. Vote Chunk. We'll see you guys next time.